Hi everyone, my name is Doğan Can. Today I will tell about car price prediction model. The aim of this project is to develop a model for accurately predicting car price in the second-hand car market by utilizing data processing, machine learning models, and prediction techniques. User will be provided with accurate price prediction based on vehicle specifications. The dataset used in this project was created by merging multiple CSV files about the second-hand cars. A total 3 million samples were obtained. After merging, some columns were dropped as they were deemed irrelevant. We removed the LTR suffix from the engine displacement column, converted it to numerical data, and then applied label encoding to prevent it being affected by label encoding, but still kept it as a categorical variable to be used in the further experiment. As you can see, 3.0 LTR to convert 3.0. To increase the performance of the model, we used label encoding on the long string values in the dataset. This technique is useful for machine learning models. We applied label encoding after converting engine displacement and year features to numerical data. This way, if necessary, we can use the two features numerically. As you can see, label encoding orange flow chart. Before after tables, as you can see, brand, year, body type, power, not power, color, full type, transmission, and location. It can be a power of the model, power increase model. We choose the linear regression model as the base model. The reason for this is the fast processing speed, quick results, and is the ability to handle a large number of features. Since our data contains a linear relationship among the features, the performance of the model is also good. Missing mileage values are replaced with the mean values of the data set. The data is grouped by year, and the mileage values for each vehicles are calculated separately. The missing values are then replaced with the calculated values, resulting in 21,000 mileage values being assigned. So this is imputation flow chart. And with the data set of the 3 million entries, but 1 million of them had too many missing values.
After
After
may I
three
ask a
years,
question before continuing?
okay,
One back slide, the previous slide, please. Here we
yes,
have save data.
yes.
Why we use this?
Because where missing
Okay, just a
values,
moment. Just a moment. Yağmur,
Yes.
why would you use this widget?
We saved our data while any protect from any issue while inputting process.
But we have already the file here.
Yes, but we are saving the after operation in there.
Okay. Fahrettin,
Hello,
what
teacher.
kind of format you save this data?
Actually, I couldn't hear this slides because I'm trying to focus on mine. I don't remember on this chart. I really don't remember.
Okay, why we
Could I
use
ask?
widget? Why we use this?
Sorry.
Sorry.
We want to merge our data and we select our rows, select rows, contribute them, group by, we select columns, edit domain, we add some domains.
I am
and
asking
the
simple question. Don't read my others.
Okay,
I'm
okay.
asking simple question. Why we use this widget in Orange?
Hmm.
Taha?
To merge columns according to some indexes, some values. Here is the value of year. The columns are year, according to year, because imputation done by, first of all, in this first select row widget, we choose only defined year and mileage values. So then we group by year and take the mean of the mileage values. Then we merge them with defined year values and missing mileage values. So we know that we impute the known year values by mean of that year's value, that year's mileage value.
Okay, what is
That's
the
all.
same format here? Taha?
Where I couldn't see it.
All right. Then Doğan Can, what is the save format?
Oh,
It's
save
the,
format. Can I answer?
Yes,
It's CSV again.
right? It is CSV, right? Comma
yeah.
separated format, right? So these are very basics. You need to know if you know what is going on here, right? Okay. Please continue.
Okay. We had a data set of the 3 million entries, but 1 million of them had too many missing values. After trying various methods to input the missing values, were we not able to fill them in a meaningful way. So we decided to separate the entries with missing values and compare the performance of the maze model. As a result, we observed an increase in the R-squared value. Taha will continue.
I think it's my
Doğan,
part.
may I ask you a question before Taha?
Of course.
As I ask all the teams, I'm asking the same question for your team as well. Why did you select R square metric as your performance metric? Your problem is regression problem. There are many other metrics like mean, absolute error, blah, 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 blah. Why you select R square as the performance metric?
The others are important, but the R square is very important because
Why?
why? Nasıl anlatabilirim? We wait, sorry.
Okay, let me continue. Yağmur.
Okay.
Yağmur, why your team is selecting R square as the main metric, performance metric?
Stabilize.
When we discussed, we thought R square was more effective, so we selected, but
Are you sure? In the class, I shown you that R square is not a good metric for performance. Taha, do you remember that example I showed you?
I couldn't remember actually, but I'm
Anybody
sure
remembers
you
that
meant
I
it.
show you that R square is perfect, but the classification, but the the mean
regression.
absolute error very big? Anybody remembers?
We also observe the mean absolute values, but next slide you will see why we choose the R square.
I am asking this question again and again. Now, tell me why you are reporting here R square. R square is not actually a performance metric. It just shows you how much you can explain the variation in the target value by using the feature values. But you would like to predict some price, right?
Yeah.
And R square does not provide anything with that.
Actually, our data set is a bit linear. So
It's
when
not
R square is
related to
increasing,
linear
is
or
also
something. R square does not tell you about your prediction. Does not tell anything about your predictions. Fahrettin, what would you use if your boss is only interested in your prediction accuracy in a regression problem? Will you use R square or something else in your project?
Actually, I'm not sure about it.
Doğan Can, what you can use? Which metric much more suitable for your project?
Yeah, it can be increase the
No,
also.
which metric? There are mean absolute error, right? Square mean error, rooted mean square error. Which
Yes.
metric you will use in your project to report your boss saying that my model is predicting good enough? Which metric you will use to your boss?
Mean absolute error and
Only mean absolute error, because you are predicting some dollars, $20, $21, I don't know, right? And you are saying
yes.
that my prediction is only different $1,000, missing 1,000 plus minus, for example. Am I right?
Yes.
So R square, how can you express the R square if it is 0.6 as on the slide? If I am the boss, what should I learn from that? What you should learn, what you learn from that 0.6, what it tells you about your prediction?
Yeah, 0.6 is good, but we should do see absolute error, mean absolute error, and
Do you
yes.
understand my point, Doğan?
Yes.
Teacher, could I add something?
Yes.
Actually, I think that we can use rooted one too. While we can use rooted mean absolute error.
Why?
I guess.
Why? In a price of a car,
Yes.
of a car, you are gonna use rooted mean square error.
Yes, the why is that we don't need minus points. We just need to take the idea of it's
Do you think that
away from it,
mean absolute error, is there any minus in mean absolute error?
Mean absolute error.
Absolute means what?
Yeah. Yeah. I remember that. Sorry about it.
So please, I think you don't know the metrics about the regression. And you are trying to solve a regression problem without knowing the metrics. It's not good for your team. So
actually we know, but
I said that the regression metrics and the classification metrics are for you, and there is just one slide for that. Have you checked this slide? How to calculate this?
Actually, I'm checking slides.
Then you need to learn this. I expressed in a half hour, extra hour, right? After the class. And I explain all this. If you are talking about with money, for example, you can only use mean absolute error. Otherwise, all the other metrics nonsense to your boss. How much this car? 0.005. What it means? What's your prediction? Taha, do you follow me?
Yes, yes. I'm going to show why we use R-square here, because we have to process prediction and
Okay, I am
actual
repeating
values.
my question for your team. What is your major metric for your model performance?
Mean absolute error.
Mean absolute error. You have to report for this. I ask the same question for every team, right? And now I am giving you the exact correct answer to you. But you are saying that rooted means square error we are going to use. Why? What's the point? You cannot use R square as a performance metric in prediction of a car price. What are you gonna do with it? Okay, continue.
Yeah, this is my part. We have a lot of missing values in instances, in samples, and those values are so important. But we tried a lot to impute them, to fill them with some values, and we failed. So we basically removed them all, and we checked the results of the according to our base model, and we see there is a increase in here. So we just do that and moving on. Next slide, please. Yeah, after we remove the duplicated values, the R square increased again, and our mean absolute error values are decreasing. Next, please. In this slide, we are discussing feature engineering, which involves selecting and transforming features in a data set to improve the performance of machine learning models. It can involve creating new features from existing ones, scaling or normalizing data, and selecting the most relevant features for the model. We will explore feature engineering in more detail in upcoming slides. And on this slide, we will be looking at how power and logarithmic transformations affect the R-squared value of our model's target variable. We observe that taking the target value for the 0.11, it actually needs degree of squared. We have 2 nines here. It's a special number for our data set. Resulted in an increase in R-squared value. Similarly, taking the logarithm of the target value with base 9 resulted in a similar increase in R-squared value. In both cases, we also saw a decrease in mean absolute error. To better understand these changes, we used an additional Python script to perform these transformations and compare the results. Next slide, please. I want to show the mean absolute error here. This is 1.1 for base taking the logarithm of base 1.2. Mean absolute error is 1.1 and others are less than 1. This is not informative. So we write our own scripts to understand what is the actual predictions, actual results. Next slide, please. We also have this script on appendix part. This is just a flowchart of this script. This takes a lot of places and we have to remove it and put in a new script. Next slide, please. Oh, could you back on previous slide? I'm gonna try to draw something, but sorry, I couldn't use it. Just look at the feature constructor after the predictions. this feature constructor taking the actual value, which is price log here, our targets, and prediction value, model's prediction value, and applying some formulas here. It's 9 to the mean absolute error. Sorry, it's 9, yeah. Sorry, I confused. It's 9 to the our prediction. Gives me the actual prediction here, actual unit prediction. We just reverse engineering.
I'm sorry, I
things.
am lost here. What are you trying to do here?
We try to find real R square and real mean absolute error.
What do you mean by mean, real?
Real, because these predictions are not real, because we change our target value. Our target is price, and we taking its logarithm. So those values are not real. We have to take actual and prediction sets and calculate them again. So those flowchart doing this, but we have also script to doing this fast. I'm going to show the formula in the next slides. Next, please. Yeah, this is the formula. Base over my, it's not, yeah. This is the one technique for the calculate the difference rate, error rate. But it's just predictions result. It's just test and score widgets result. Next slide, please. Also, we find 9th is the best for the taking logarithm base. The formula in the appendix. After the slide, we can show it. Previous, please. We tried. We found a high correlation between engine displacement and power, and we try to derive new feature, but we always face to face with decreasing R square and increasing mean absolute error, because engine displacement feature is better when we use it as class categorical variable. When we taking this feature as numeric, we get worse result. Next slide, please. As you can see, there is high correlation, and as I said before, those values are not real, because it just changed targets. Next slide, please. We failed for other features engineering part. And our final data set compared with initial, we lost a lot of instances because of most of them are duplicated, and some of them are garbage because they don't include important features, important values. We remove some features, those are meta values, and final dataset doesn't include any missing values, doesn't include any duplicate instances. We applied label encoding because to increase in power, not to check all the string values. We didn't apply one-hot encoding to final dataset because we may need to reverse it again. So we just pre-process when we run into models, and we only change feature price. That's all. Next slide, please. This is informative feature statistics for initial data set. Next slide, please. Next, please. Yeah. Do you have any questions?
So, Fahretin, did you present anything? Did I miss?
We have two,
we
we have
will
two
continue
slides.
with model selecting part. Fahretin and I will continue with model
We
selecting.
last 10 minutes.
Okay.
We can try to finish that, actually. Okay. Yağmur will start.
Okay. Could you next please. Our experimentation, we use supervised learning and regression applied.
Please pass over this because we have only 9 minutes.
Okay,
We are
okay.
gonna be graded about for 5 minutes. So please tell me more things about what you have done so I can grade you correctly.
Okay, as you know, it's one of the initial part of the processing, split the data set. Next, please. And we tested linear regression SVM models due to the linear nature of our data set. Additionally, we tried the random forest models, and we also tested the KNN model. Next, please. Here is the event regression. Next, please. Here is our compare part and test and validation. Of course, we did according to the.
Okay, I am again saying that for your project, R square is not your main metric. Do you understand this? Now
Yes.
you are reporting with R square.
Yes, we had a little confusion about the R square issue. Next, please. And here there are bridge regression results, values
May I
actually.
interrupt you? Sorry, as you can see, we observe Maya also, and not only R square. Sorry.
Yes.
But why you have these test result here?
We just try to compare because
You
which is
cannot
fast
do this.
and we
You cannot, it's cheating. As I explained, when you try to tune your
Yeah, after,
parameters,
yeah.
you cannot use test data. Yağmur,
those are two different tests, two different
I am
runs.
repeating myself, Taha. Do you listen me carefully? In hyperparameter tuning, you never and ever use test data. Do you understand me? You only use
Yeah,
train and validation data. You cannot select a hyperparameter value according to the result of test. It is cheating.
I see. So,
And Yağmur, why did you do this? We have only 3 minutes to continue.
Okay, we can continue about that. Next slide.
Yes.
Yes, I can continue about it. About L2 regressions. Next slide. We try to combine them as test and validation results, and we look at when we look at them, it's look like they are closing together, and this alpha points. Other slide. About the KNN, other slide. When we look at the KNN, our square points are
13 and 14, and the even numbers are not suggested. Why you are using 14? What's the reason for that?
The reason for that, we try to look every point of the data which we are using.
Even numbers are not used.
May I answer?
Okay.
No,
I can answer.
No, I am asking to Fahretin.
Yes, I can.
2 minutes.
We look at every points on this data, and
no, you didn't check the points. I am asking. not the data. I am asking the value of K. I am not asking about data. I am asking a value for the hyperparameter K. Why did you use 14? In the KNN with K 14. In the
Yes,
class, I said that we don't use even values. Why did you use an even number 14? I am just wondering.
Yeah.
Why?
We are looking every point, not 13, like
I am
13.1.
asking again,
Like,
Fahretin. I said that in the class, you cannot use even numbers. The even numbers 2, 4, 6, 10, 12, 14. You cannot use these numbers. Why did you use 14? You cannot use even numbers in KNN.
yes.
It's a common thing because it
Yes.
is major voting.
Yes, I remember that.
Decide this. Why?
I remember that. We just want to draw a line for showing the results.
Anybody understands me? Anybody that?
Actually, I understand.
Nobody understands me. So I am asking even numbers. Do you know what is the odd number and even number?
Yes.
Yes.
I am asking that you don't use in the world the Chinese people, the Indians people, the Russians. Nobody use even numbers. Why? Fahrettin is using even number. Why?
Can I say it?
Yes.
I discovered in internet. I see it's even numbers reduce the computation time.
No, it's major.
Yeah.
Major.
May I answer?
It's major.
So we have regression here, so it's calculate the distance. Am I right?
Continue.
Okay, other slide.
Hmm.
The data which the data of the table which we showed
Now
on the
look at that data. 10, 20, 30, 40, 50, all of them even numbers.
yes. Actually, I didn't use 13. I just know that
All of them
we should use
even numbers. Why?
because for Kenan we are using even numbers. Maybe I can get confused, but I don't remember. I just remember that we couldn't use odd numbers because we couldn't group them as odd. I'm not really sure right now. Sorry about it. Could my any friend answer that, and could I continue the slide?
Please continue. You have only 3 minutes.
Okay.
Okay, 1 minute.
Okay, about the CMV, we can continue.
SVM.
SVM, sorry. When we experiment with SVM, we encountered and insecure and get unsatisfaction about the results. Even after conducted with a grid search, we found that increasing the interaction improved the results, but it also significantly slowed down the model. Other slides.
Excuse me, which data set you are using?
The data set which we are using, the labeled and encoded as.
No, I am asking that this is the pre-processed data set or not? This is the data set that Doğan Can explained me.
The last data set, yes.
Are you sure?
No, this is the after script results. This is the scores.
Doğan Can, do you understand what I am talking?
Yes, the four features are actually we have a script. It's the script results. That was, as you can see, it's not
Do you
our data
understand
set.
what I am talking?
Yes.